Good morning, this is your Stat Sensei, and we're going to do the test corrections for our last test, which was the test of means. And this video will cover scenario 1. There'll be 3 videos in total. So when a virus is placed on a tobacco leaf, small lesions appear on the leaf. To compare the mean, and by the way, this tells me the type of test I'm running, the mean number of lesions produced by 2 different strains of the virus. One strain is applied to half of each of 8 tobacco leaves. So that's important. We know that we have a sample size of 8, and the other strain is applied to the other half. So we have half of being applied to one side and half being applied to the other side. So we're being tested twice. And if we're tested twice, we know we're working for a paired t-test. So we're tested twice. Okay? The strain that goes on the right half of the leaf is decided by coin flip. This is going to be important because this is telling me that we're using random assignment and we're assigning it by coin flip. The lesions appear on each half and then are counted. The data are given below. Now, if I wasn't sure about whether or not it was a paired t-test, consider this. I have 8 leaves, but I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16 different measurements. So if I have 8, my sample size 8, but I've tested it 16 times, obviously things have been tested twice. And once again, if it's tested twice, it's a paired t-test. And that determines how we're going, which formula to use and how we're going to approach this. So the first thing, determine at the 1% significance level, and I know this is a change from usual, whether or not there is a difference, and this tells me whether or not it's going to be a not equal, in the mean number of lesions produced by the 2 virus strains. Well, our null hypothesis is that there is no difference. And that's really important that we notice that it's mu d equals 0. The alternative is, mu d equals 0, and here it's something other than 0, which indicates that there is a difference. We always must define our parameter. So let mu d equal the true population mean of the differences. And it's mean of the differences because we're finding all the individual differences. Basically, this minus this, this minus this, this minus this, this minus this, and taking the average of all of that, and the number of tobacco virus leaves. And we're going to go, and I subtracted in order of strain 1 minus strain 2. You could have chosen the opposite order, and that would have been fine, but I just went with strain 1 minus strain 2. One thing to point out to you guys, if they give you this is just a sample mean to check to see whether you input your data correctly. All right, so let's take a look at this. Our conditions are random sample. Well, no, this was random assignment, and it was random assignment given by a coin flip. Now, you don't have to tell me how it was done, but it's pretty nice to do so. Lets the grader know that you really know something and you're on top of it. So random assignment, and it was given by coin flip. Our sample size was 8, and you can either do 8 divided by 0.1 or 8 times 10. And there were more than 80 tobacco leaves. And I guess I should say there are more than 80 tobacco leaves. And the sample size is less than 10% of the population. So we're okay with that. It's reasonable to assume that the number of lesions on one leaf will not impact the number of lesions on another leaf. That's the independence. So the difference in lesions is independent. Now we need to go ahead and check for normality because our sample size was small. Our sample size was 8. We can't say it's normal by central limit theorem, and they didn't tell us the underlying distribution was normal. So at this point, we're going to go to our calculator. We'll go to stat edit, and we'll enter all the data. Now I'm going to just do a real quick check here. I'm going to go stat calc, one variable statistics, and I'm going to go to list L1. And I'm going to say, oh, yeah, 13.75. I entered that data correctly. My standard deviation matches 5.8. All right, so that matches. So I've entered that data correctly. And by the way, we can scroll down and get our 5-number summary down below for that, but we don't need that for this test. Stat calc 1 variable stat second 2. It's like, okay, standard, I got a sample size, sample mean of 11. So that matches. And my sample standard deviation also matches. So I've input my data correctly. But we're looking for the differences, which means I need to subtract every single one of those, which I can do by hand, or I can go to the calculator and I arrow up to the top of L3 and I go second 1 minus second 2, and I get every single one of the differences. At that point, I have stat, calc, one variable statistics. My list is an L3. And now I have some important information that I need to note down. All right, so my sample mean, etc. But here's the part that I really care about. For right now, I need to do the box plot. And so here's my 5-number summary, my minimum value, my Q1, my median, Q3, and Q4. When we actually go to create our box plot, we go to second, then stat plot, press enter, make sure it's turned on. And I got an X list, needs to be L3 because that's where my data is, or that's where the differences are. Zoom 9. But when we're doing a test, paired t-test, all we care about is the box plot of the differences. And once again, we can use the trace feature. I can't even see the buttons. There we go. We can use the trace feature, and it'll actually give us the measurements. And when we just look at this, it's like, you know what? This is reasonably symmetric, definitely has no outliers. It's okay to proceed with the normal. So the box plot is reasonably symmetric, no outliers. The distribution appears to be approximately normal. And once again, when I went to stat calc, one variable stats, I got a sample mean of 2.75 and a standard deviation of 2.3145. My degrees of freedom were 8 minus 1. All right, so my formula is T equals X bar D, and we need to make sure we have the D's in there, SD divided by the square root of N. So I'm going to plug in, I'm going to plug in the 2.75 here, 2.345 there, and 8 is my, make sure that you're using 8. Some people use 16, that was incorrect. All right, and this is what bothered people. It's like, okay, what's the mean? What is my mu D? Mu D we said was 0. That's what our assumption is. Our assumption is that there's no difference. So this is our mu D equal to 0. Now, a lot of times students ask me, well, how do I know which symbol to use? Because this was a not equal test. So how do I know to use a greater than? Well, I'm going to go ahead and run this thing first off. And well, there's two ways to look at it. First off, 2.75 is greater than 0. So we have a mean of we have a mean of 0, but we ended up getting an X bar of 2.75. Well, that's above it, so that's greater than. And then we know, because anytime you have a not equal to, you need to go 2 times the probability. So that's why it gives me that. And I go ahead and run this test, and I go stat test, drop down to t-test, and I have data this time, so I select data. My mean is my null hypothesis of 0. My X list is an L3, and I can go ahead and run this as a not equal to, and I end up getting my t statistic of 3.36, which equals 0.0121. Now the calculator automatically doubled it, so it's already doubled it for me, and I can prove that to you in just a second here. So if I went stat calc one variable, stat test t-test, and I just change this to a greater than, I end up getting 0.006. Well, 0.006 needs to be doubled because it's a not equal to. So, all right, be careful with that. So I just use the not equal to symbol on the calculator. So my p-value is 0.00120, which is greater than the alpha level that they told us. So our decision will be to fail to reject the null. So our p-value, this is our conclusion. Our p-value is 0.0120. We fail to reject the null. So this goes here. This decision goes here. There is not sufficient evidence at alpha equal 0.01 to suggest the true population mean of the differences in tobacco leaf virus lesions strain 1 minus strain 2 is different than 0. This was our null hypothesis, our alternative hypothesis. Because our alternative hypothesis was mu d does not equal 0, so different than 0. And this right here, true population mean of the differences, that was our let statement that we had above. Let mu d equal the true population mean of the differences in the number of tobacco leaf virus lesions, strain 1 minus strain 2. Now, what can we say? In common words, and I want you to get used to writing this down, wasn't required, but get used to writing this down. At the 1% level, in other words, at the alpha level they give us, what was they actually finding? Our actual finding in common words is our study does not indicate that one virus causes more lesions than the other virus, because we basically said, hey, it wasn't different than 0. We failed to reject. So if we failed to reject, we didn't believe this, we were stuck with that. So that's what we believe the null. And if we believe the null, it was like, hey, it does not indicate a difference. So get in the habit of saying that statement. What is the meaning of the p-value in the context of the study? Well, I always like to start off with what it says of the definition. Well, the definition is the p-value is a probability of getting a test statistic this extreme or more extreme in favor of the alternative, given that null is true. If you just gave me that gets you no credit. And if that's the only part that was right, you also get no credit. However, it did buy some help if you were not quite perfect on the second part. Some people got full credit depending on what they said. Some people got partial credit. So in this case, there's a 1.2% chance that we would get a test statistic this extreme or more more extreme in favor of there being a difference that came from my alternative in the number of virus lesions, when in fact there was no difference. And no difference would be my null. All right. So make sure you always put it in context. All right. Always have to put it in context. And you need to practice writing these, because there's several people, they got points here and several people didn't. So please be careful about how you state that. All right, thank you for watching. The next video will cover the second problem. All right, thank you.